Hi, this is S. Lakshmanachari, working as Assistant Professor in Department of Cyber Security, Institute of Aeronautical Engineering, Hyderabad. In this lecture, we are going to discuss the topic of parallel processing. So, parallel processing we are using in multi-processor system. So, parallel processing is a method to improve computer system performance by executing two or more instructions simultaneously. So that is called parallel processing. So it is a method. So by using this method, we can able to improve the computer system performance by executing two or more instructions simultaneously. So in the multiprocess systems, we are using this parallel processing concept, and using this, we are improving the computer system performance. Okay. So, a parallel processing system can carry out simultaneous data processing to achieve faster execution time. So, that means simultaneously it can able to perform different simultaneous data processing operations. Okay. And for instance, while an instruction is being processed in ALU component of the CPU, the next instruction can be read from memory. So, when one instruction is fetched from the memory, and that instruction will be processed in the ALU component of the CPU. So, while the first instruction is in the fetch phase, while so when the first instruction, the instruction it will be fetched from the memory, and then it will be decoding, and after that the instruction will be executing. So these are the different phases of the instruction. So when the first instruction is it is in the phase of the decoding, while the first instruction is in the phase of decoding, the second another instruction will be fetched from the memory. Okay, so another instruction will be read from memory. So in this way, two or more instructions are executing in simultaneously in parallel, so that we can reduce the access time, and then the computer speed will be improved. So the primary purpose of parallel processing is to enhance the computer processing capability. So mainly we are using this parallel processing for the two reasons. One is to improve the computer processing capability, and the second one is the increasing the throughput. So these are the two reasons why we are using the parallel processing. So first reason is enhancing the computer processing capability. So using this parallel processing, we can increase the processing capability, and also we can increase the throughput. So throughput is the amount of processing that can be accomplished during a given interval of time. So the throughput means it is the amount of processing that can be accomplished during a given interval of time. So that means using this throughput, we can measure the performance of a system during a given period of time. So suppose if you consider a POS mission, point of sale mission. So using this point of sale mission, we can able to swipe a card, debit card or credit card. So that means per second, how many swipes are performing through the POS machine. So that means the number of transactions per second of a POS machine. So that determines the throughput of the POS machine. So in this way, the throughput of the throughput can be determined. So see here. So if the instructions of the program are executed in sequential manner. So in olden days, the computer will process the instructions in a sequential manner. Okay, so it takes more amount of time to execute all those instructions of the program. Okay, so suppose if you consider a program. So this is let us assume the program. Program is nothing but it is a collection of instructions. It is having multiple instructions. Instruction 1, 2, 3, and so on up to instruction n. So every instruction, it has to be undergo the three phases. First one is a fetch, decode, execute. Fetch. What is fetching? Fetching means in general this program, it will be stored in the memory. So from the memory the instructions will be fetched. So fetching is nothing but retrieving. Fetching is nothing but retrieving the instruction from the memory. Okay, that is called fetch phase. After fetching, we need to decode the instruction. So decode. So decoding is nothing but we are writing the programs using some high level language, low level language, or the assembly level language. So because these are the human friendly languages, so we can able to understand to write and read the programs. But as a machine, it cannot understand the high level language or machine or low level language, because the machine can understand only the machine language, nothing but zeros and ones. So that's why the instruction which is written in the human understandable language, that should be converted into the machine understandable language. That means that instruction we are converting into the zeros and ones. So that is called decoding. That is called decoding phase. After decoding, then the CPU will determine the what type of operation it has to perform, and finally it needs to be executed. So executing, suppose if you have a instruction, assembly instruction, add al comma bl. So this is one assembly level language. So when what is the type of operation here? So add. So add means addition. So finally, after fetching the instruction and decoding the instruction, then this addition operation will be performed. So these are the different three phases of the instruction. Okay. So in a sequential manner, all the instructions. So the first instruction, it will be fetched, decoded, and executed. So when the first instruction execution completed, then only the second instruction will be fetched from the memory. So next instruction, it will be fetched. Again, it will be fetch. After that, it will be decoded, and after that, execute. So whenever the second instruction completed the execution, then only the third instruction will be fetched from the memory. So like that, all the instructions in the program will be gets executed. So if you observe this sequential access, it takes more time, because the time required to execute the program, it will be increases directly proportional to the number of instructions in the program. If the number of instructions in the program are very more in number, then the time required also will be increases. Okay, so to overcome that, so we are using another method. So that is called parallel processing. So what is parallel processing? So see here. So here this is a sequential approach. So in sequential approach, the first instruction will be completed, fetch, decode, execute, and after that the second instruction fetch will start. Okay, after completion of the second instruction, the third instruction will be the third instruction fetching will be started. After that, decoding, next execute. So here the time required to execute the program will be more. Okay, so that's why the computer performance will be degraded, because it is taking more time to execute the program. So that's why the computer's performance will be degraded. Okay, so in order to enhance the performance of the CPU, we are using a parallel processing concept. So parallel processing concept. So what is parallel processing? Parallel processing is a method. It is used to improve the computer system performance by executing two or more instructions simultaneously. Okay, so by using this parallel processing concept, then we can enhance the computer system performance. So a parallel processing system is able to perform concurrent data processing to achieve faster execution time. So in parallel processing system, we are able to perform concurrent data processing. Concurrent data processing. That means we are executing two or more instructions simultaneously. So let's see how it will improve the speed of the execution. So this is a three-stage pipeline instruction execution. So three stage. That means this is a first stage, fetch. Second stage, decode. Third stage, execute. So every instruction, it is having three stages: fetch, decode, execute. So that's why it is called three-stage pipeline instruction execution. So let's assume the program, it consists of some three instructions. Instruction 1, 2, 3. So the first instruction, it will be fetched from the memory. After that, it will be decoded, and after that, it will be executed. So in parallel processing, when the first instruction is in the phase of decoding, the second instruction will be fetched from the memory. Similarly, when the first instruction is in the execution phase, then the second instruction will be decoded. Okay. So similarly, when the second instruction is in the phase of decoding phase, the third instruction will be fetched from the memory. So in this way, that means here, so one or two or more instructions are processing simultaneously. So that's why we can improve the system's performance, because here the access time, the execution time is reduced. The execution time is reduced so that we can enhance the computer's performance. So the modern high performance CPUs like MIPS, million instructions per second, use a technique called pipelining technique. So nowadays in high performance computers, we are using this technique, we are using this method called the pipelining concept. So whereby these phases of the instruction processing are executed in independent overlapping stages as shown. And coming to the parallel processing system, have two or more ALUs and be able to execute two or more instructions at the same time. Also, the system may have two or more processors operating concurrently, and also in a multiprocessor system, it may have two or more processors, so that they can share the task, so that the computer's performance will be improved. And using this parallel processing system, we are going to increase the throughput. And if you consider a basic computer system, mainly it has three functional parts, that are memory, I/O devices, central processing unit. So these are the three important functional parts of the computer. If you look into the CPU again, the CPU again, it consists of three essential parts, that are ALU, arithmetic and logic unit, control unit, and the internal registers of the CPU. So these are the three sub parts of the CPU. So the CPU, it consists of ALU, control unit, and the registers. So if you look into the ALU, so ALU means arithmetic and logic unit. So ALU, it will perform different arithmetic and logic operations. So arithmetic operations are addition, subtraction, multiplication, division, like that. And the logical operations are AND operation, and OR, XOR, complement, increment, decrement, So these are all the logical operations. So this ALU, it can able to perform all these arithmetic and logical operations. So if you look into the ALU, inside that it is having different multiple functional units. Inside the ALU, we will have different parallel functional units are there. So that are adder, subtractor, integer multiply, logic unit, shift unit, incrementer, floating point addition, subtraction, floating point multiply, floating point divide. So these are all the independent units. So all these independent units, they are able to operate individual or concurrently. Okay. So so these are, we have a processor registers. So all these functional units, they will receive the data from the processor registers. And after that, they are performing the operation, and again the results will be given back to the registers, and the data which is stored in the processor registers, we can send to the memory too. Okay. So suppose if the instruction needs to be performed, some addition and shift operation and incrementer and floating point divide. So the instruction is able to perform these operations. Then that the units which are corresponding to these operations should be operated. So addition, add or subtractor. So this unit should be operated. After that, shift operation. So shift unit. Next, incrementer. Next, floating point division. This one. So all these 4 units corresponding to the addition, shift operation, incrementer, and floating point division. So all these units, they have to operate individually or concurrently, so that the required functionality can be achieved. Okay, so these are all the functional units or independent units. So these are all independent. So only they can operate individually or all together, so that the required functionality can be achieved. So a multifunctional organization is usually associated with the complex control unit to coordinate all the activities among the various components. So the parallel processing can be classified from the internal organization of the processors, the interconnection structure between processors, and the flow of information through the system, and the number of instructions and data items that are manipulated simultaneously. So the parallel processing can be classified like this. And coming to the Flyn's classification. Okay, so Flyn's classification. So this Flyn's classification, it was proposed by Michael J. Flyn's in 1966. In the 1966 year, the Michael J. Flyn's, he proposed a computer's classification. So that computer's classification is called Flyn's classification. Okay, so it is the most commonly acceptable taxonomy of the computer organization. And in this classification, the computers are classified by whether it process a single instruction at a time or multiple instructions simultaneously, and it is whether it operates on single or multiple data sets. So based on this, the computers are classified into 4 types. So based on how the number of instructions operating at a time or simultaneously, and also these instructions are operate on a single set of data or multiple set of data. Okay, so based on this, so the computers are classified into four types. First one is a SISD, single instruction stream, single data stream. Second one is a single instruction stream and multiple data stream. Third one, multiple instruction stream and single data stream. Last one, multiple instruction stream, multiple data stream. So these are the four types of the the computer classification under Flint's classification. Okay, so let's see what is instruction stream. So instruction stream is the sequence of instructions. It is a sequence of instructions read from memory, because the memory, so we are storing a program in the memory. We are storing a programs in the memory. So in every memory location, we will store one instruction. Instruction 1, 2, 3, 4, 5, and so on. So a sequence of instructions is called instruction stream, which are read from the memory. And similarly, data stream. So data stream is not, so instruction stream is nothing but it is a memory. And similarly, data stream. So data stream is the operations performed on the data. The operations performed on the data in the processor. So that is called data stream. So because this data stream is nothing but it is a processor. Because the data will be stored in the internal registers of the processor. So that's why the data stream, it can be considered as a processor. So that means, see here. So in SISD, single instruction stream and single data stream. So that means here we have a one processor and one memory device. And in SIMD, we have one processor and multiple single instruction stream. So one memory and multiple processors. And in MISD, multiple instruction stream. Multiple instruction stream means multiple memories. And single data stream. Single data stream is one processor. And coming to the last one, multiple instruction stream and multiple data stream. That means multiple processors and memories. Okay, so these are the Flint's classification. So parallel processing may occur in the instruction stream or the data stream or the both. So this parallel processing, it may take place on any of these streams, either instruction stream, data stream, or both. So let's see one by one. So first one is a SISD, single instruction stream, single data stream. So it represents the organization of a single computer containing the control unit, processor unit, and the memory unit. So it represents a single computer that consists of the control unit, one control unit, one processor unit, and one memory unit. So instructions are executed sequentially, and the system may or may not have internal parallel processing capabilities. And most computers have SISD architecture, like the traditional von Neumann computer. So the traditional computers the traditional computers are the olden days, like in 1960s, 17s, we are using this type of SISD and single computer. So single CPUs will be considered as a SISD architecture. That means a single instruction stream and single data stream. And parallel processing in this case may be achieved by means of multiple functional units or by parallel processing. So here we have a memory unit. So this is a memory unit. So instructions are coming from the memory unit. So these instructions which are coming from the memory unit are given to the control unit So the control unit will decode that instructions, and further that decoded instructions are applied to the processing unit for the execution. Okay, so the instruction stream will be given to the processing unit, and this instruction stream is a unidirectional from the control unit to the processing unit, whereas the data stream is a bidirectional between the processing unit and the memory unit. And the control unit, it is also able to communicate with the IO devices. And the examples of this type of computers are the older generation computers, mini computers, and workstations. And if you come to the advantages of the SISD, this type of systems requires less power, and here there is no issue of complex communication protocol between the multiple cores. So here in this SISD systems, we have only one processor. So that's why here there is no issue of this complex communication protocol between the multiple cores. And coming to the disadvantages of the SISD. So the speed of SISD architecture is limited, just like single core processor, because here only we are using a single processor. So that's why the speed also limited, and it is not suitable for larger applications. So where very high performance is required, there we cannot use this type of systems. So that is a drawback of this SISD. And coming to the second type, that is a SIMD, single instruction stream and multiple data streams. So it represents an organization that includes many processing units under the supervision of the common control unit, and all processors receives the same instruction from the control unit but operate on different items of the data. The shared memory unit must contain multiple modules so that it can communicate with all the processors simultaneously. So here the name it represents single instruction stream. That means we have a single memory. So we have a single memory and multiple data stream. That means multiple processors are there. So see here. So we have a memory. We have a shared memory, single memory, and that memory it is shared by different processors. These are the processor units. So these are all the different processors. They are able to share a common memory. So that is called shared memory. Okay, and all these different processors, they are operating on same set of data. So they are using all the different processors. They are using a single memory. That is called the shared memory. And examples of this type are array processors and vector processors. And advantages of single instruction, multiple data stream, or same operation on multiple elements can be performed using one instruction only. So using one instruction, then we can perform the same operation on multiple elements. and throughput of the system can be increased by increasing the number of cores of the processor. So by increasing the number of cores of the processor, then the throughput of the system can be increased, because here the number of processors are increased. So that's why the throughput can be increased. And the processing speed is higher than the SISD architecture, because here previously we have used only one processor, but here more than one processor we are using. So that's why the processing speed is higher when you compare with the SISD architecture. And coming to the disadvantages, there is a complex communication issue between the number of cores of the processor. So here the number of cores are more. So that's why the CPU has to communicate with the other CPUs. So that's why here there is a complex communication protocol problem, and the cost is higher than SISD architecture, because as the number of CPUs increases, the cost of the system also increases. So that's why the cost is higher than the SISD architecture. Now coming to the third one, MISD, multiple instruction stream and single data stream. So we have a multiple instruction stream. So that means multiple memories and a single data stream. So single processor and multiple memories. Okay. So MISD structure is only of theoretical interest, since no practical system has been constructed using this organization. So in MISD, multiple processing units operate on single data stream. Each processing unit operate on the data independently via separate instruction streams. So see here. So multiple. So here the single processor is able to operate on different multiple memories. So this is only exists for theoretical concept, but practically this type of system is not existed. And coming to the fourth classification of the Flynn's classification, that is a MIMD, multiple instruction and multiple instruction stream and multiple data stream. So that means here in this type of systems, we are using the multiple processors and the multiple memories. Okay. So in this organization, all processors in a parallel computer can execute different instructions and operate on various data at the same time. So see here. So every processor, it is associated with a corresponding memory. Okay. So like that. Okay. So this type of systems can be considered as a multi-processor system. So that means multiple processes are able to run concurrently, so that the system's performance will be improved. So in MIMD, each processor has a separate program and an instruction stream is generated from each program. So the examples of this type of systems are Cray T9, T90, Cray T3E, and IBM SP2. So these are the examples of the MIMD systems. So in this lecture, we have discussed about what is parallel processing, and also we have seen the Flynn's classification, and we have discussed about each classification. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.